All right, welcome to the after work video. It's 5:05. So let's do an hour of this and then hopefully go swimming. So, so we finished the topic in the previous video, and now we're moving on to learning about MTU issues and IGPs. So last video, we figured out a way to detect an MTU issue using trace options. All you need to do is do trace options flag all, and then save that to a file, and then you can do show log, and then the file name, pipe match, and then MTU. And if there are any MTU mismatches, you'll get a message showing you the MTU setting on both sides. So that'll come in really handy during the test for OSPF, but we also got to do it for ISIS because that is also going to be an IGP that has issues if the MTU settings do not match. So I will share my screen. Okay, and then I will open up my lab again, and we'll convert the IGP that I was using in my lab from OSPF to ISIS, and then we'll see if we can use that same strategy with trace options to detect a error. Okay, but first things first, converting this. Oops, and one thing I wanted to do the last video was to convert it using a jump host, just because I want a better understanding of cutting off my legs and losing access. I want that to show up on the video, but unfortunately there's an issue where I can't configure it using the DHCP setup I have on router 1, but that's, I think, okay for now. I'll just add a IP addressing manually. Okay, so I'm going to need to look up how to do this. So I can do a history, type grep ifconfig. Okay, so this is how this is done. Oh, so there's no add, it's just ifconfig eth1. Oh, and it's going to be .6/30. Perfect. So now I need to make a network address. There we go. Yep, but it's going to be. Oh, you know what? I bet you that's the problem. Okay, yeah, that's the problem. So the reason I'm not able to get DHCP working is because right now, if you look at my DHCP pool, you can see I've got it set up for the network .4/30. But if I look at the IP addresses that are configured on my interfaces, you can see that .4/30, that network is configured on GE008 by way of the host address .4. So if I do a run show route 192.168.4/30, you can see it's a direct route via this interface. But that interface, if I do a match on it, is the interface to guest 2. So it's no wonder guest 1 isn't getting an IP address because the interface to guest 1 is going to be, I believe it's 9. Let's take a look. Yep, so it's going to be 9 to guest 1. And then 9 has the 0.0 network. So we're going to need to do another pool. Yeah, so we're going to need to make another network for it to use. So I think it will need to be just another pool. I guess I'm not sure how to do this, but let's find out. So we'll call it guest-1 for the name of the pool. Oops, so edit pool guest-1 family inet, and now set network. Okay, set range, and then we'll do single IP because it's going to be okay, and then of course that's the low range, so then the high range. Okay. Now let's not set this to infinite this time because we do want it to time out if it doesn't have it. So let's set it to 10 seconds. Let's set it to even 5 seconds. Okay, and then we're going to need a default router, which is going to be that one. All right. Okay, so everything looks good. I'm going to take another look at the configuration of GE009. Yep, so this is going to serve as the default router. It's going to get past this IP, and then it will not hold on to that IP indefinitely. Okay, so now hopefully it works better. Although I did actually add this on here now. So let's do an ifconfig. Okay, so I've got that on there, but I have a feeling it didn't come from DHCP. And then the other problem, of course, is I'm going to have 2 default gateways. Yep, so even now, yep, because it's not in the, so let's do a route add net 72.16.0.0. And then it's going to be, okay. Oh, 248 gateway. See if that's 0.1. Okay, so I don't need to use the term mask, and then I can use the CIDR notation. Perfect. Oops, network is not reachable. Oh, that's interesting. Oh, right, because I put .6 on there instead of the correct one. So I'm just going to reboot it, and hopefully it'll get the correct one. Oh, so it looks like it failed to get a DHCP lease. All right, so let's look into that. I wasn't expecting this to be this complicated. Nope. And so for somehow okay, well, this is why it failed to get released, because somehow I reconfigured router 1. Yeah, I think this is kind of a fool's errand to just use the Docker guest to configure everything. There's no reason I can't use it on the console. I think during the test you'll just have console access to everything anyways. There's no reason. I kind of wanted it to be a little bit more like it would be in production, and kind of have to think a little bit more about how I'm interacting with the devices in terms of what my source IP is, which I think is very valuable to understand how you're connecting to the device in terms of what the actual traffic looks like, which you don't really get if you're out of band, because you're actually not using the traffic. But if you're in band, then you're actually sending packets and frames, so you've got to be aware of the details. All right, but let's just go to router 4 and start to convert this from OSPF to ISIS using the console. Okay. Okay, so OSPF, we got a few differences between OSPF and ISIS. OSPF doesn't require anything on the interfaces for Junipers. All it requires is this protocols OSPF configuration. So that's different from ISIS, because ISIS you will require some interface configuration, but I'll start by changing the protocols configuration first. Okay, and I just get rid of everything under here. And now I can do edit ISIS area. Oops. Yep. Now it's a lot simpler under here. I just add the interfaces that I want. So let's see what those are going to be. Run show int description. Okay. So yeah, the protocols configuration is really easy. Yep, and then we're going to need 1, and we'll need 2, and then we'll need 1 more interface. So 3, 2, 1. Can you guess which one it is? That's right. It's the loopback interface. And you don't have to specify .0. You can save yourself some typing because it puts it in there automatically. So we need a bunch more steps. We're going to need to set interface GE00.0 family ISO, and we'll need to do that for all of the other ones. Okay, but that's all that's required for the physical interfaces. For the loopback interface, we're going to need to assign it an ISO address. So it goes 49, and then the area ID, which is going to be area 0, and then just something that matches the address. So let's have it go, yep, a false like that. So we've got it saved in our buffer. And then we'll do a run show int LO0. Oops, sorry. We'll do a show int LO0. There we go. So now I know what to add for this portion of the address, which escapes me what it's called. I did in the 960 version get through a large part of ISIS, but I don't remember what the details are of this. Okay, and then they all end in 00, so this is going to be good. So, yep, so let's do a show pipe compare to see what I'm going to be adding. So I'm going to be adding ISIS config and removing OSPF config. Okay, so router 4 is going to no longer be reachable. So hopefully that other router is up now and I can reach that. Let's see if I've got an IP. Nope, I still don't have an IP. Oh, looks like it's not done booting yet. All right, so let's move on to router 3. Okay, and we'll need to make the same kind of configurations. Before we do that, let's do a help and see if we can easily find a way to learn more about that NET, Network Entity Title. Okay, so we've got examples, policy options, help op. No. So here we've got examples. So unfortunately, this really doesn't give you the whole picture because it just says to enable protocols, but you will need to enable a NET identifier. It doesn't even tell you that that is necessary in this. Okay, but this is good to know. Because ISIS does not operate at the network layer, it is more difficult to spoof than OSPF, which is encapsulated in IP and is therefore subject to remote spoofing and DOS, denial of service attacks. So definitely ISIS is the way to go if you gotta pick one for your ISP. Okay, yep, but unfortunately, really not enough to know how to do it properly. Okay, so let's just move on. Oops, so set ISIS, and then it's going to be interface. Oh, before we do that though, let's do a run show in descriptions, see which interfaces need to be added. Okay. All right. Oops, and I'm gonna, yep, have that fill out so it's in my buffer and then do a run show, or actually show int LO0. There we go. So it's going to be 49.162.0.162.116.163.00. Perfect. So now we've got router 2 and router 1 left. Oh, it looks like router 1 is back up, so maybe we can do the configuration remotely. Nope, it didn't hand out the IP again for some reason. I'm not sure why that didn't happen. I'm actually kind of surprised. So yeah, we've got the pool. Okay, yeah, everything looks fine there. Okay, so let's see, what about show DHCP statistics or server binding? Okay, so we've got nothing there. Okay, yeah, so I'm not sure what's going on here. But it's okay, we're doing fine manually, so let's just continue out of band configuration instead of in band, since we'll have out of band on the test anyways. So this is interesting. We've got some trace options files, or trace options enabled here. Oh, we got to do a run showing descriptions. There we go. So, yep, and then it's going to be, so set interfaces, family, oops, I got to do unit 0, family ISO. So this is where network automation would help me on the exam, because this is a lot of time lost, and I've only got 6 hours to take the exam. So depending on how much configuration it is, 6 hours could, in fact, not be enough. Unless I use automation. Oops, and I forgot to do address. So I forgot, let's do a show int LO0. All right. Okay, so I should have 2 neighbors by now, or adjacencies rather, as they're called in OSPF. They're called something different in OSPF. Yep, and I've got level 2 and level 1 adjacencies, but I do have them with the 2 devices I've configured so far. So that leaves router 1. Okay, so router 1, we've got some extra interfaces we're going to need to include. The interfaces to the Ubuntu Docker guests, but we can make them passive interfaces since the Ubuntu Docker guests won't need to have that ISIS control traffic. Oops, and I like to do a show interface descriptions first, make it nice and easy on me. I'm gonna have to do a run because I'm in config mode. Perfect. Eight and 9. Okay, and then of course we'll need the loopback interface as well. That's mandatory for ISIS. Big difference between ISIS and OSPF is that it is mandatory in ISIS. OSPF, it's recommended to have a loopback or a router ID configured because it's going to do a election for the designated router, the backup designated router, and then all of the DR others. And the winner of that election is based on the highest IP address that is either configured manually as a router ID, on a loopback address, or on a physical interface in that order. So if you don't have the manual, it uses the loopback. If you don't have the loopback, it uses the physical interface. So it's recommended to only set up that router ID so that you know who's going to be the winner of that election, and things aren't just randomly distributed out. Okay, so let's go top, and then, yep, let's do a show configuration, or let's do a show into LO0 and set interfaces LO. 0, 1, unit 0, family ISO. Okay, so that looks good. How about LO0? Yep, and then of course this requires an address. Okay, so now all of the routers should be up, and I should be able to ping them. So this one is having issues with DHCP, but I've got another host here. I guess I could have done that in the first place and could have done them all remotely just by using the second host. But every once in a while there's like a huge flashing. It's probably my lamp or something. This lamp eats up light bulbs really fast. All right. Yeah, I've only got one light bulb left. There's normally 3 there, but due to coronavirus world B, there's restrictions on maintenance requests. So normally I just put in a maintenance request. There's a whole category for light bulbs, but it's only emergency maintenances are going to be billed now in world B. So, but I have an extra lamp if I need it. All right, so let's continue on with this exercise and stay focused. So in order to do that, so we do have a IP address, so let's see if we can ping everything now. Perfect. So we successfully changed it from OSPF to ISIS. So let's start a Wireshark capture between R2 and R4, just as we did before. And then Oh, so there's still one running, so I can get rid of that. And then we'll try enabling some trace options and changing the MTU on both sides to be so that they don't match, and hopefully see how we can make that easy during the test to discover. Okay, so router 2 and router 4. Oops, and okay, there we go, there we go. Okay, perfect. So let's go back into the configuration. So edit protocols, ISIS. There we go. So now set trace options. Flag. Okay, so much like OSPF, I don't see anything for MTU specifically. I do see something for error, but let's just go with all. File, tshoot, ISIS. Okay, so let's do a monitor start on that. There's probably going to be a lot of chatter. But I can always stop it if there's too much chatter. So you have lots of chatter, but let's just keep that running while I change the MTU on this side. Okay, so I'm going to be changing the MTU to router 2. That's going to be on interface 001. Okay, so I don't see an option to set the interface. Let's try going to top and then edit interface 001.0. Let's do a set family ISO and see if there's, yep, so there's MTU under here. So it doesn't give us the range here though. Let's do a help topic family. Oh, don't have it. So reference family or ISO. ISIS MTU maybe. Nope. So can't get any help for that. Yeah, let's just pick a number. So it's going to be set family ISO MTU, and we'll have it be 999. There we go. Commit. Perfect. Okay. So now hopefully that adjacency goes down. Oh, I thought I saw something, so I'll do a monitor stop. Yeah, so it's adding a reach neighbor. Let's do the show log tshoot ISIS pipe match MTU. Okay, I don't see anything. What about adjacency? Okay, so I don't see anything for MTU. I'm going to try setting the MTU on this side as well. So this will be GE002. Okay, and then it's unit 0, family ISO, MTU. We'll set this to 1000. Okay, so let's do a show ISIS adjacency. Oh, so yeah, we can see this is in initializing now. It's stuck in initializing. Yep, so we can do a pipe refresh 1. Oh, so now it went to down. And this is the level 2 went to down. The level 1 is still in initializing, but now both the level 2 and the level 1 are down. So let's see if we've got, nope, still nothing for MTU in uppercase, and still nothing in lowercase. So unfortunately for ISIS, it's going to be a little bit more difficult. We don't have trace options that'll make it nice and clear what is going on. Yeah, that's too bad. I mean, the good news is we do have that for OSPF, so the OSPF section is going to be a lot easier. But I mean, to be honest, just doing show runs and writing down the values carefully on a notepad, that sort of thing, is going to be probably the best bet anyways. One thing we can also do is search for pipe match 999. And we can also search for 1000 because those are the MTU settings. So if they show up, it will match under those numbers. So it looks like there's a value that is 999, but it looks like it's not the OSPF, or sorry, it's not the MTU value. So here's the packet. We can see that these are not, these are all frames. So we don't have any IPs in here because it's ISIS. It's not a layer 3 protocol. In fact, it has its own addressing. And it is a link state protocol though, like OSPF, so you will have LSPs for every link in the topology. Okay, so yeah, I think what I'm going to do is just reestablish that. It's kind of too bad that it doesn't have anything for me for trace options. Well, let's try trace options under family ISO under the loopback. So we're going to do int LO0 0 family ISO, and nope, no trace options there. Any here? Nope, no trace options here. Now there are trace options here, but it's going to be, I don't think there's anything relating. Yep, so it's just for physical interface. Let's try it here though. Oh, so to set the file, I've got to go up another level. Okay, so we're going to do int or tshoot int. Okay. Yeah, I'm just curious if because there's a ISO address on that interface that I'll get to something So we'll do a monitor stop. I think it was already stopped, but I'll just do it again. And then do a monitor start, tshoot, int. And I'm just curious to see if there's anything to do with ISIS on there. So what if I do a show configuration int, or sorry, show int, display set relative. Okay. So now it's going to be, yep. Oops, but we don't want show, we want edit. Perfect, okay, so delete family ISO MTU. Or let's just do a set. Okay, so now it's going to match the other side, and we'll see this come back up, and we'll be able to see if there's any trace options. So it looks like it completely disappeared off of here when it went down. It didn't just stay there and then stay down. It just completely went away when there was an MTU mismatch, which is interesting to know. But hopefully it comes back now that those sides match. Oop, and we did get some trace options data. A lot of it, actually. Oh, you know what? Okay, yeah, I think this is because of, we're getting that data because of my automated script. No, I don't have a script on here. I have a script on R1 only. Okay, yeah, so I'm not sure what this data is, but I don't see anything particular to ISIS, which is what I was wondering if there would be messages for. So there aren't any, so I'm going to do a monitor stop. Okay, and then a show ISIS adjacency. Oops, but it looks like it's still not coming up for some reason. All right, so let's do a show configuration. Set, pipe match ISO. And then we'll do a pipe match ISIS. Okay, and we'll do the same thing on this side. All right, so let's see what the difference is here. Okay, so here it's not passive, but it was fine before. It was up before I made this change. So I wonder if I've got the right interfaces. So this is going to be router 1, yep, to router 2. And then this is router 2. So it's got to go to router 4. Yep, so it looks like it's got the MTU set correctly. I wonder if that MTU is too small is the problem. So let me get my adjacency up. Yeah, so I think the problem is that the MTU is too small. If we open the Wireshark capture again, and we look at the length of the packets, so I have the MTU now set to 999, but okay, well, I don't see anything bigger than 999. Let's just take those settings off and see if we get any bigger packets. And I'll do a fresh capture before I commit both sides. So I'll do configure private and then show pipe display set. Okay, so now I can just do delete and it'll just delete that part. Show pipe compare. Yep, you can see it looks good. Show configuration, pipe display set. Okay, so now we can delete this. Oh, configure private, delete. Show pipe compare. There we go. So now let's get a fresh capture. All right, and now let's see how big those packets are, or well, they're not packets, they're frames, they're ISO traffic. It's particular to ISIS. So let's see how big they get. And perhaps 999 was the reason, was because it was too small. Yep, so that's exactly the reason. We've got some hello packets here, particular kinds of hello packets that are larger, and we can't establish that connection because we were having our MTU be smaller than that size. So let's analyze those packets and see what's special about them that make them so much bigger than all the other ones. Okay, so it looks like they're just regular old hello packets. It looks like we've got one, so we've got, basically we just have two of these, but we have one for each level. So we have one coming from 2E04 MAC address, which we'll figure out which device that is. So 2E04 MAC address. I'm thinking that's going to be the MAC address of the loopback interface. So I'm going to do show int LO0. So the MAC address. Nope, I don't see the MAC address listed. So let's see what the system MAC address is. I think it's show chassis MAC. Yeah, there we go. So yep, now we've got a public and a private MAC address. So nope, I don't see that at all. So it's not going to be the system MAC address. Maybe it's the MAC address of the port. So that would be port GE002. Yep, so it's the MAC address of the port. We've got 0C6308, 0C6308. It's the vendor code, so it's going to be the same for all of them since these are all Junipers. So that's the OUI portion. And then we've got the unique identifier. So this is 362E04, 362E04. So this is router 2. And then this is router 4. So we can see that router 4, the first packet, or the first frame we're getting is from router 4. But then we get some from router 2. And let's see why the ones from router 2 are so much bigger than the other ones. Aha, so it's because there's a bunch of extra padding on this. And there's also a new field, this neighbor field on here. So it detected a neighbor, and because of that, it added extra padding to make the packet bigger. But when we were restricting the MTU size down to 999, we weren't allowing these packets, which are essential because you can see they have that ISIS neighbor portion to them. So they're very clearly used to establish a ISIS adjacency. And it's interesting because it looks like we've got more after that that still have that that neighbor field to it, but no longer have the padding. So yeah, that's interesting. Okay, but I think that's the end of this video. I accomplished all the goals I had. So yep, so I'll mark this as done. So yep, I saw what happened when you had a mismatch with ISIS. The adjacency went down and then it just disappeared. So yeah, so I'll make my notes for this being my second video on this series. Oh, I didn't use this at all. I meant to do that. I just used the trace options. Yeah, so let's try this command here just quick before the end of the video. Okay, so we didn't get any oversized frames, which I'm surprised by. I would think that we would get 2 for a total of 4. We get 2 on router 2 and 2 on router 4, but maybe the counter is cleared or something. But this does seem like it would have been pretty helpful to figure out what that problem was. But we figured it out, so let's just move on. But of course, that is something I'm going to need to remember on the test. I think I kind of neglect those interface statistics sometimes a bit too much. This looks pretty good. Okay, so this is the MTU configuration between Juniper's and Cisco's, but I just need to learn about MTU issues for IGPs. Yep, and yeah. Okay, so I'll include this in there just so I have some notes in there. All right, and then I'll mark the end of this MTU issues. So next video will be about authentication for IGPs. So thanks for watching, and I'll see you in the next one.